Okay. Hi everyone, I'm Abby, and today Rudolph and I will be sharing a little bit about our experience as NUS Chem students. So, firstly, welcome to NUS Chem Eng. I know that coming to uni can be quite overwhelming because everything is new, but I hope our sharing will help you ease up a little. So, a little bit about myself. I'm Abby, currently a year two Chem Eng student, and I was previously from National Junior College IP program. I took physics, chemistry, math, and econs at H2 level. And if you guys took bio, you don't have to worry too much because most of the courses they start from the basics, so you guys will be fine. And there's also a physics bridging course that you guys will be allocated to, so you guys don't have to worry so much about it. So right now, I'm also doing a minor in data analytics, and I'm quite interested in taking up a specialization in process engineering. Outside of academics, I'm also involved in a few CCAs and student activities. So currently, I'm part of Chemical Engineering Student Society, the NUS Student Union, and the Community Service Club, and lastly, the CD Club. I think one thing I really learned in uni is that your uni life does not have to just be about your degree. Like, of course, academics are important, but there are also so many opportunities for you to explore your interests, meet different people, and grow in ways that you might not expect. So, why Chem Eng? For me, one of the best things about chemical engineering is how diverse it is. Before uni, I think many people think of Chem Eng as chemistry and labs, but I think it's actually much more than that. In Chem Eng, you get exposed to different areas from cell kinetics to fluid dynamics. And because of that, I feel like there is really something for everyone. Whether you're more interested in sustainability, energy, pharmaceuticals, data analytics, or process engineering, I think there's likely a part of Chem Eng that connects to your interests. So another thing I really appreciate is the learning environment. The profs I've met so far are super passionate and approachable, and many of them really try to make learning enjoyable. And of course, some modules can be challenging, but I think learning them is what makes it fulfilling. Yeah, so on this slide, you can see some of my photos from my lab sessions. So we have my poster day from CN 2102, where we were supposed to brew this kombucha and present our findings to our profs, which was quite fun. And then I also have pictures from my first ever Chem lab. So these experiences also helped me get to know my cohort mates better because we worked in groups and completed our weekly reports together. Yeah. So moving beyond academics, one of the more meaningful experiences I had was Project Chiwe, which is an overseas community involvement program for chemical engineering students, and I served as the vice project director for it. I feel like Project Chiwe gave me the chance to be exposed to so many new experiences, people, and skills. I got to organize fundraisers, design shirts that people actually wore around school, and lead my amazing team. And I thought it was pretty cool. Seeing my members get closer to one another and closer to the locals in Cambodia was very fulfilling. And exploring Cambodia with these people was really fun. I think what made it especially meaningful was that it reminded me that engineering is not just about the calculations and the technical knowledge we learn for exams. I think at the end of the day, engineering is also about solving real world problems and creating impact for the people around us. So another exciting experience I had was winter school in South Korea at Hanyang University. I had so much fun with my closest friends from Chem Eng while also clearing the EG 2401A module. And I think it was honestly such a nice balance of academics, traveling, and making memories. And we got to experience studying in another country, explore Korea, and spend time outside the usual NUS environment. So one funny moment is that if you can see the picture of me and my friend Ashley in cowboy hats, the exact same night we actually got news that we were going for a student exchange program to Texas. So I thought that was quite a silly moment for us and definitely a core memory for me. So I think winter school and exchange opportunities are something you can really look forward to in uni. And I think they allow you to step out of your comfort zone, experience different cultures, and see learning from a different perspective. So when opportunities like that come your way, I really encourage you to consider them. Yeah. So lastly, I want to talk a bit about CCAs and student life. So on this slide, you can see some of my experiences. So I'm currently part of the CHES Exco, the Chemical Engineering Student Society, and I serve as the secretary. But I've also been involved in various other programs under CHES, such as the Freshman Orientation Program, which you guys should definitely check out if you guys are coming for Chem Eng. And also, I took part in the Chemical Equilibrium Challenge, Chem E Challenge, where I got to share more about Chem Eng to pre-U students as well. And I'm also quite involved in community service and the community service club because I think um, it helps me spend my time more meaningfully there. And I'm generally at my happiest when I'm volunteering. So being involved in CCAs really helped me grow as a person as I took up new responsibilities and discovered what kind of environments I really enjoyed working in. I also met so many new friends from different majors via these CCAs, which I think was pretty cool. So with that, I've come to the end of my sharing of my year one and year two experience, and I'll hand my time over to Rudolph.
Yeah. Hi, everyone. Can you hear me? Yeah. Hi, everyone. I'm Rudolph, and I'm currently in year four. And today I'll be sharing a bit more about my background. Then followed by my experiences in year three and year four about internships, specializations, and final year project in NUS Chemical Engineering. So, just to share a bit about my background. So, before entering NUS, I actually studied chemical engineering at Singapore Polytechnic. And during my final year there, I interned with the SP Data Science and Analytics Center. So, actually, towards the end of poly, after the 3 years in chemical engineering, I was actually looking to pivot out, exploring the different possible like career pathways at that point of time. But after a certain period of time, I actually during NS I actually realized that I actually missed what I studied in poly, especially when it comes to process simulations and solving like engineering related problems. So working with like Aspen HYSYS and models, I realized that that was something I really missed. So why I'm sharing this is because during your as incoming students, right, during your course, during your time in Cambridge, there may be points where you may find like a certain concept is you may struggle to understand like these certain concepts, but I think one key important point is to highlight the things that you love about the course, and then use that to get and figure out what you want to do for your career. Then afterwards, after matriculating, I chose to specialize in both process engineering and biopharmaceutical engineering because I wanted to deepen my understanding of chemical engineering while exploring these different industries within the field. And then, similar to RB, outside of academics, I've been involved with the Chemical Engineering Student Society as well, where I helped in the planning and organization of activities such as competitions, industrial talks, networking sessions, freshman camp, as well as overseas community projects. I felt that these experiences really helped me grow outside of academics. I'm actually quite an introvert, so it actually helped me make me a bit more outspoken and then better at like presenting. Um, here are some of the. Oh, so here are some of my experiences. So one of the best parts about university is really about the experience and the people you meet while you are going through your this 3 or 4 years journey that you have. So since Cambridge is can be quite demanding at certain times. So having friends to go through like all the assignments, labs, and exams together really makes a very huge difference. So then, outside of academics, joining CCAs and the overseas project also taught me a lot about communication, teamwork, as well as adapting to different environments. So, if you do have the chance do look out for these opportunities, especially during the year one and year two, where the technical difficulty of the course is still relatively manageable. Then now moving on to year three. So in year three, typically you'll be doing your graded internship. So for graded internships, usually there's two ways for students to apply for internships in NUS. So firstly is through Talent Connect, which is the school portal where companies will put their postings for internships there. So it's actually quite simple. You just need to look at it and then just apply when if you are interested in a certain role. Then secondly is through self-sourcing. So what you could do is like contact companies, email HR to see whether they have a spot for you, which was what I did actually. So for which is what I did for my internship since yeah, which I'll explain a bit later. So for chemical engineering, one good thing about chemical engineering is that our skill sets are extremely valuable for across different industries. So because of that, there are actually many different pathways that you can explore, such as like a career in oil and gas, chemicals, pharmaceuticals, semiconductors, as well as research roles. So this is only a very short list, and there are a lot more options out there. Just mainly stating the ones that where I saw most of my friends like ending up working for as well as interning in. Then for my internship, I worked at Novartis in the pharmaceutical industry. So you can see the picture over there where I'm wearing like the gowning suit. Yeah, it's not easy to put on. It's quite warm in it, but everything in the pharmaceutical facility needs to be very clean. And it's also air conditioned lah. So it is not the most pleasant thing to wear, but it's also not exactly like horrible lah. Yeah. Then one thing that I learned during internship is that while the technical knowledge is important, but how you communicate with your colleagues as well as how you show initiative also matters a lot. So when you guys get to that stage, I know it may seem a bit far, but trust me, the time passes by pretty quickly. I still feel like a year one from time to time. So when you're at the workplace, don't be afraid to ask questions, clarify doubts, or volunteer for tasks because that's where a lot of the learning will come from. Especially since you're an intern, so people are more accepting of you making mistakes since that is somewhat the expectation lah. Yeah. Then another tip will be try to understand the bigger picture of what your team is doing instead of focusing on just your assigned task. So one good opportunity that I had during my internship at Novartis was that I actually got to help out with the audits, which helped me which put me in contact with like all the different departments within the organizations, which I thought honestly one of the best learning opportunities there was because you understand like, oh, what this department does, what this other department does, and how everything links together. So piecing all these like different puzzle pieces together, right, is how you can actually better understand the industry and then figure out whether like that specific industry is the one that you want to join. Then in year three and year four, so another thing that you could be possibly be interested in is also specializations, where currently NUS Chemical Engineering offers four different specializations, each with its own focus areas. For the specifics, I think you can probably go onto the website because as a final year student, I think since you guys are just coming in, some things may have changed already. But yeah, so these are some of the modules that I took for when I was pursuing my double specialization. So since I was interested in entering the pharmaceutical industry, I decided to take like pharmaceutical mods where it will give me a better understanding of the industry while at the same time taking control and optimization based process engineering mods. Not sure if these terms sound a bit foreign. I think maybe like sharing this, right? Maybe at this point you may not really get a feel of like what I'm saying right now, but I think eventually maybe like in the back of your head, maybe someday 2 years later you realize, oh, I understand what he's talking about right now. Yeah. Then for the specialization mods, while the modules were not easy, but many of them were extremely interesting because they were very application based and then closer to like actual industry practices. So for example, in the troubleshooting with case studies course that I took, so we actually worked with or we were given like problems by industry professionals So I think we had three different case studies. So people from like the industry come in with their with a case study, and then we work on those case studies to try to solve like the problem that they had, and then we had to propose our solutions to them. So that was that course was extremely fun, and it made the learning experience like much more engaging and meaningful. And then some of the modules that I took under process engineering was also very relevant to to my year four final year project. So such as optimization and pinch analysis and process integration. So I actually suggest that you look into these modules as well, because taking these modules actually helped me understand the certain final year project concepts and gave me a bit more confident when approaching those topics. And it actually gives you a slight advantage. Although grading wise everyone is graded based on the same basis, but you would have that like extra step of understanding compared to your peers when you do your FYP. So moving on to the final year project, FYP. This is one of the biggest components in year four. Frankly, this I think this was where most of my time went to during my year four in chemical engineering. So new week, new problems. Okay, but to give an introduction first. So for FYP, you will need to design a chemical process facility based on a set of customer requirements that are given by the professors. So instead of like solving like test questions, right? You'll be more of using your understanding of what you learn throughout your 4 years in chemical engineering into presenting and creating this project where you need to hit a certain like target. So here below you can see like some of the key topics, many of which you will learn in your earlier years. So having a strong foundation will definitely help you a lot later on. So do pay attention during your year one to year three, and then learn them well, because you everything builds up towards the end. So I also included some tips for FYP. I understand it's a bit far out right now, but like some things. Like for me when I was doing, I realized a lot of things is hindsight lah. So it's like while in the process of the project, I realized that maybe in my year one to year three, maybe I could have prepared a bit better. So hence that's why there's this slide right now. So one of the toughest parts of FYP is that there is no single right answer. So you'll be constantly making like design decisions and justifying them and adapting along the way. So it really pays to plan ahead and then give yourself like that extra buffer time. So actually, I think for my team, we actually plan like to finish probably I think 2 to 3 weeks before what we intended to do. But because new week, new problems, we have new problems. Suddenly something goes wrong, we need to solve that. So it really is actually very very important that you give yourself that buffer time. Then also make sure that you have a good grasp of all the core modules, as well as make sure that you communicate well with your team. So for example, I think there was this one point at the project where we had to do a lot of like we had to redo a lot of the work, because one person was using an old file, the other person was using a new file, and then we had to reconcile everything. Then when we reconcile everything, we realized that, oh, wait a minute, this doesn't work when it's together. We need to find a way to mesh everything together. So you can actually save a lot of time by like just making sure that everything is very, very organized when you do your work. And then last but not least, I think for as incoming students, maybe this point is a bit more relevant. So it's best if you speak to some seniors, learn from them, and pick up any skills or software that you may require later on while you have the time and the capacity to learn those right now. So, for example, for me personally, I feel that I'm a bit weaker when it comes to coding. So when it comes to like generating this kind of graphs, right, this was actually mostly done by my teammates. But yeah, it was a bit slower for me when I had to learn and understand all this. So so one thing in hindsight, I really wish that I actually maybe looked a bit more into like creating this kind of visuals and then learning how to do this kind of optimization methods. But also it's like you don't know what you don't know. So at least now that you guys have a hint of like what might have the kind of problems that you may face in the future, right? So then maybe it might lead you to design your curriculum in a certain way to prepare for this situation. One thing that I really appreciate about the NUS Chemical Engineering cohort is how open everyone is about sharing information. So personally, I've received a lot of help from both my peers and seniors throughout the year. So um, chemical engineer, I think maybe because we are all like struggling or suffering together. So we are like everyone is trying their best to adapt to the curriculum because it's quite rigorous. So don't be afraid to reach out to all the friends, seniors, as well as the professors as well. So as we don't really keep much lah for NUS chemical engineering students, and we have a very friendly environment, and it will help your learning process, speed up your learning process as well. So I think that pretty much wraps up like what I wanted to share about FYP. So now before we close off, we would like to leave you with some final words. I'll pass it to Abi first.
Okay, so like my final words is that uni is super fun, and I think it's a time for you to step out of your comfort zone and experience many new things. And don't be afraid of the academic rigor because as long as you stay consistent, I think you can cope very well. And don't be afraid to ask for help, like Rudolph said just now. Yeah.
Then for me, to add on to what Abi said, for many of you, I think for uni will probably be the like your bachelor's will probably be the last chapter of your schooling life before you step into the working world. So make it count. So make friends. Don't forget to enjoy the process, and don't be afraid to make mistakes along the way. So maybe for example, like for me, I started off as more of an introvert, but I tried to put myself more into situations where I can speak up a bit more and then develop. So I think uni is honestly one of the best and also a less harsh like environment as compared to like if you were to go to the workplace and then start making mistakes there. Yeah. So we hope that today's sharing has been helpful and we wish you all the best in your journey ahead. Welcome to NUS Chemical Engineering. And now I would like to pass on the time to the Ying Jun for her presentation.
Hi, can you hear me? Okay, all right, perfect. Well, that was a very nice presentation. I don't have any slides to show you guys, but I'm just going to talk about my experience in school and my experience out of school as well. The like the two of them, I think my 4 years in uni as a chemistry student was a bit more unique. I focused really also a lot on things outside of the academic career. So I spent a lot of time being a volunteer, and I led the volunteer group as well. I don't know whether it's still around. It's called NUS Volunteer Action Committee, MVAC. Um, and and during my time, right, it was we have about 400 volunteers, and you'll be surprised to know this, but a lot of my peers, a lot of my EXCO at the point in time, were from ChemEnt. Well, they were my batch. So I think there was, 10 to 20 of us in the volunteer group as well. So there's a lot of a lot of community bonding, and it does help, right? So they share a lot of what is the current curriculum and what you're going through. It's definitely much better than back then in our time, when it was much more rigorous, and much more less suitable for current times, right? Going forward, after I graduated, I took on a slightly different path from most of my peers. I went to focus on capital projects. And that led me, especially in the first half of my career, to do projects in many different countries. I was in Mozambique, I was in Rotterdam, Netherlands, I was in China, I was in Malaysia. And then basically we were doing a lot of capital projects like building terminals, process plants, in different parts of the world. And that really opened my eyes as to how different things are being done in different countries, right? Some of our consideration of logistics, of regulations, of even manpower planning, and even your engineering requirements and how you should design basic, even a PFD, your PNID when you design the process flow. Those considerations are all different because of different areas. And I do not think that without that time in my life, I don't think I will be where I am today, right? And as a project person, um, it's very rare to see, it's much rarer to see chemical engineers as project people. Most of them, especially in the early 2010s, majority of them were actually from mechanical and less from chemical. But that is where the chemical engineers have an advantage. Because we understand the process flow, because we understand process control, and that makes us in a position to better understand how the entire project flows from the engineering all the way to commissioning and startup, and that also enables me to pick up all the steps along the way and really expedite my project knowledge as well. And which is also why as I progress along, I got to be involved in a lot more very interesting projects in different parts of the world. And I managed to move from a contractor to an owner, whereby on the owner side, you're really looking at how projects can really drive business value, how projects can really bring about even better economics and also better process control and safety for the plant and whatever you're doing as well. And after I came back to Singapore, I got a bit sick of doing capital projects in the refinery, and which is why I think a couple years ago, I decided to move to do strategic procurement. And at the same time also, I was also doing my Master of Law in international business because doing as a project person, you handle a lot of contracts. And hence, my interest in law was ignited. And because of my background as a chemical engineer and because of whatever academic rigor we had to go through, that also helped me to apply the same academic rigor to my law study. And this is also why, although I'm one of the few non-law students in the whole in the whole class of law students, somehow I managed to graduate valedictorian, right? So for those of you who think that chemical engineer may not do much help, it does help you in different ways as well. And thank you, Tae Yong. It's a coincidence, but Tae Yong is actually my classmate. We were in the same class. So I don't know how Coco did it, but she managed to find 2% from the same batch and same class. Right. But so moving on, um, over when I was doing my master, I realized that my interest was still back in capital projects, which is why I'm doing a role now as a consultant for capital projects, and we focus on doing benchmarking of capital projects and also how advising clients on how to build governance for capital projects as well. So this is just an example of how chemical engineering is not only for pharmaceutical or process chemical industries. It can also be used in a wide variety of other careers. I think a lot of our batch came out and they also went into many industries such as finance, and they are doing pretty well as well. And that understanding of engineering also helped them to bring a very structured work, bring a very structured lens to doing investment. Right. And I think that's part of my sharing for now. Take you on some slides, I believe.
Hi everybody, give me a moment. Let me just share my slides. Uh, Yeah. So I'm here to talk a bit about my career journey. So so I think maybe I this slide is not so good because it gives all of you an idea when we graduated. So we graduated some years ago, okay, quite a number of years ago. We so in June and I we actually entered chemical engineering in 2002, graduated in 2006. So for myself, my first job was with JGC Singapore. I started as a process engineer, so got into process design where we design all the equipment for various plants across the region. So you have to do things like vessel sizing, heat exchanger sizing, piping sizing, pump sizing, and then you have to design all the flow diagrams from process flow diagrams to piping and instrumentation diagrams and things like that. So I was there for maybe 7 years. Then I changed company. I went to JGC Singapore is basically a engineering consultancy. So they help um, plant owners execute projects, right? So I went on. So from a consultancy, I went over to Infinium. Uh, so I joined the process engineering team. No surprises. Uh, and then I worked so in a plant it's a bit more different. You don't have you, although I was a process design engineer, it was not as dedicated or specialized as the one working for engineering consultancy. You have to do a lot more different things. Yeah, kind of the bridge between the plant and the engineering companies that provide solutions. So you have to understand what the plant wants, translate what they want, and then you let the engineering company know. And then you have to manage the schedule, manage the construction, manage a host of other things such as even deliveries of materials, when you need to take them, and things like that. And then after that, in 2016, I moved from uh, process designer to plant technical leader. So basically, the plant technical team is consists of engineers looking after all the process units in the plant. So all the job of the engineers is basically to optimize, to troubleshoot, and also to steward key production metrics, run reports and things like that lah. So I help the team to steward all these responsibilities so that the plant can operate effectively, safely, efficiently, and also continue to deliver production to a high level. So, and after that, so I was there for another 4 years. After that, I moved out from the plant in 2020, where I moved into a role called CTS Technologies. It was a kind of a research and developmental role, kind of like a scientist, but with a view to the customer. So it is also technical in nature, but it's a little bit different from what I was doing uh, in my previous job. So if I were to give an analogy, so the plant related activities, you kind of like you make the coffee powder, right? In the plant, you just make the coffee powder. Every day you make the different types of coffee powder and then you produce it. Make sure that the coffee powder comes out. So as a technologist, you kind of like this kind of try to develop the coffee powder, right? So to fit the needs. So basically, we are developing chemistry solutions to fit the customers. So Infinium is a chemical specialty company. So our technologies primarily run with lubricants. Uh, so a lot of our technologies go into vehicles. So your all your different engine oils, your gear oils, your transmission oils, things like that. So those technologies help to deliver power savings. They help to make the engine last longer and things like that, right? So I was there for another 4 years, and then in 2024 I moved into a whole new uh, part of my career. It's a bit different, completely different from what I've done before. Because what I've done before was all technical, and then 2024 I moved into procurement as a category and services leader. So there's two parts to the role. One is procurement category leader. So there are different categories of procurement. You have raw materials, you have logistics, you have research and development. So all of this you engage different suppliers. So as a category leader, you drive the category strategies, and then you drive all the vendor strategies in the category. And then as a services leader, you are basically operational in a sense that you are running all the contracts, you're running all the tenders, and then you're engaging directly with the vendor to drive and unlock value for the company as well. So through either collaborative relationships or partnerships with vendors, right? So I think part of the interesting things in my career. So when I first graduated from NUS, I knew nothing, right? So I joined JGC as a process engineer. So that part of my career was very useful because it helped me to really solidify all the chemical engineering knowledge that was picked up in school in NUS, right? All the heat exchanger, heat transfer, mass transfer, what we used to call unit operations. I don't know what you call it these days, but basically how all the different uh, distillation towers and all your separation mechanisms work. Yeah. So it will help to really solidify my my all the things that I've learned as a chemical engineer. Um, and then there was I mean I also went a bit around the region. Went to work in Malaysia, went to work in Japan. So back in the day, when I just started working, Singapore was actually a low cost, well, lower cost than Japan lah. So I went to Japan because Singaporeans are lower cost. Now, of course, this has changed lah. Singapore is now higher cost than most other countries. So so the world does change. So we have to learn how to unlock value from that as well. So it's important that to recognize that as well. So we also need to add value to ourselves as well. So as an engineering specialist in Infinium, I had to work across different engineering disciplines, electrical, piping, mechanical, cost, scheduling. So I had to balance all this. So that's where I developed knowledge outside of chemical engineering. I know a bit of mechanical requirements. I know a bit of electrical requirements. I know a bit of how process control systems work, the logic and things like that. I know how to roughly manage project schedule, how to identify which are long lead items, and how to make sure that you have a proper plan for them to deliver in time so that you don't affect the project schedule. I learned how to manage costs because you only have a fixed cost to manage, and then if anybody has done any renovation before, the costs only go up, they never go down one. Okay, so you have to manage all these things and make sure your stakeholders are happy. Uh, and then so this taught me other disciplines, how to work with other disciplines and how they go hand in hand with chemical engineering to deliver the complete uh solution, the final package to the customer or the plant rather. So in Infinium, as a plant technical leader, this what I learned from this was beyond engineering. I learned how to interact with stakeholders in the company. For example, uh, I learned why. I mean, besides knowing how to design the plant, how to troubleshoot and all that, I learned about why we want to do certain projects. What is important about this project? What does this deliver for the company? Like because we had to do economic studies for projects. Like, okay, if I do this solution and I produce X tons more, how does it help the company? Is it worth it to invest say Y amount of money and then to get X return? When will I get the return? Is it worth it? Things like that. And then so you have to work with different stakeholders, all the business sides of things, like to understand, hey, what are your numbers? Why do you want to do this? What's the justification? This is then you have to do the cost estimate. Okay, this is the amount of money I need to deliver this amount of facility, right? And then after when I moved on to the technologies, which is really the R&D role. Now the R&D role is actually what drives development in the plant, because when you make a new product, then the plant when you make a new product, design a new product, you're doing it sort of like in a lab, in a limited scale, but in a plant, you're doing it on a large scale. So when you make a product, you also need to consider, is this thing doable in the plant? Is this temperature doable? Is this pressure doable? Is this viscosity doable? If the viscosity is too high, then it's not pumpable. Then how are you going to go, then you need to consider these things. And then beyond that, I also have to work with customers to deliver, what they need, right? So I have to understand what is their requirements, technical requirements. I have to talk to them, engage with them, and then help sales to, of course, get the business as well. So we have to do a bit of marketing to sell the product. Okay, and then after that, I went to procurement. I think it was because I had a lot of background in technical, so that's why I went to. So when I first started in procurement, I was in charge of all the maintenance and engineering and things like that. So I was overseeing procurement for all these items. So yeah, so all these things kind of lead to other things. So in procurement, I interact with vendors, and I'm in charge of the span across some categories of uh, spend. So I help the business functions to formulate strategies with vendors, how to unlock value, and help them to help the business functions to actually work with external partners to deliver value for the whole company as a whole. So it's so along the way I learned a lot of things lah. So what I want to say is you can start in engineering, but what engineering gives you is the base and knowledge to allow you to expand your horizon. You start, just looking at numbers and things like that, but along the way, you get to know people, you get to, look at the macro picture rather than the micro picture. And then along the way, you develop and you learn. So, learning is never a static process. You always continue to learn. So like I think in terms of chemical engineering, the things that you learn, like mass transfer, heat transfer, all these things will always continue to be useful as long as you need to move materials around, as long as you need to heat up things, you need to cool down things, you always need chemical engineering. So it's never going to be a dull industry to be in, yeah, because it does gives you that base to to step up into more things, right? Yeah. So I think with that, it's the end of my presentation. I shall stop sharing and I'll hand over the time back to Coco.
Okay, thank you so much for our students and alumni for your amazing presentation. So now we'll proceed with the Q&A section. For students who want to ask their questions live, you can unmute yourself. But students who prefer to type it out, you can do it through the Q&A section. We have received a question from Wan Ting. Hi, Professor. I would like to ask your advice regarding the computer specifications recommended for chemical engineering students. As I am preparing for my studies, I would like to ensure that my laptop will be suitable for the software and coursework used throughout the program. Could you kindly advise me on the recommended specifications or software requirements that students usually need?
I can quickly answer that. What we do is actually any baseline laptop you can buy these days, Windows or Apple, should suffice, because all the specialized software you actually have access to via the department, right? So, and most things will run on any state-of-the-art laptop. You don't need something like with a graphics card and all of that. Those kinds of computing resources we have at NUS. So really, in fact, if you have a decent laptop right now, it should be fine.
Yeah. And yeah, I would just like to add on that we do let you install some of the software in your laptops. So you could actually use them on your laptops as well as you could use it in the department computer labs. So for one of the software, it works with Windows system. It's called Aspen Hysys. So the simulation software which you'll be using in year 4 and also for your year 3 course. it works on Windows system, but for Mac, you need to install Parallel. Yeah. So
Yes.
yeah. So for that one, sometimes for some students it has not worked. So in that case, it's still not the end of the world. You can still use the computers in the computer lab. That's what they do. Yeah, and maybe I'm not sure which system does Rudolph use, Windows or Mac, because he has just finished it.
Windows.
Most of our students are
Mm.
Windows.
Yeah,
A lot of our professors are Mac.
yeah,
It's interesting.
yeah. So just that other point that I want to add. Yeah. So in case you are looking to choose between Windows and Mac, yeah.
Okay, we have one more question. Hello, Professor. I would like to ask for more information of biopharmaceutical engineering specialization in chemical engineering. Is it suitable for my future intention of working in cosmetic and healthcare fields? Thank you for answering.
Yes, absolutely. Because if you think really right, it's all about manufacturing practices in the biopharmaceutical industry, which translate to healthcare, to cosmetics, translates to foods, right? So yes, yeah, definitely. And you can choose multiple specializations. Yeah, Rudolph just showed you that you could do like a couple of different specializations, right? So no problem. So that's the second question that was.
I'm sorry. Oh,
Yes,
for me,
Alicia, you
it's
had a question?
Alicia. Yeah, thank you for like the presentation. I wanted to ask if like there was anything we could do now to like prepare for the course that we are about to go into. Because like we have like a lot of time on our hands now. So I was like wondering if there's anything we could do. Like, yeah.
I'll let Suraj answer that question first because this is a very common question we are asked. And then I'll provide some perspective as well. Come, Suraj, why don't you go first for this one?
Okay, sure, Prof. Yeah. So I would suggest that you can I believe you're from A level. Yeah. Alicia, yeah. So if you're from A level, what I would suggest is revise some physics and maths, most importantly, because we will be using quite a bit of maths in solving our problems across all the courses in chemical engineering. And I think there are some very nice introductory books about chemical engineering. Maybe Prof. Khan can suggest some good titles for you. Yeah, so I would suggest that if you want to get an idea of what chemical engineering is, so you might actually look for one of those books and yeah, get a better idea of what our discipline is about. Yeah.
So I think the what Suraj points out, right? Just
Yeah.
refresh your math.
Yeah.
By the way, math, you're entering engineering, right? Doesn't matter what engineering you enter,
Yeah.
right? When you start off with, you need math for all engineering because that's our language for design and for prediction, right? So you could refresh that. That's one. I think, at a larger scale, to all you students on this call, what I would suggest is one great challenge that I see students encounter these days is the ability to just lock in and focus on reading anything, you know? So if you want to really productively spend your time, it doesn't have to be a chemical engineering book, but read a book, read something hard, okay? And what that does is it gets you in the mindset of actually reading and comprehending long form stuff, which will inevitably help no matter what you do. And I think that is a challenge, right? So that would be my advice. So you can brush up on some math. All the comments that we need to teach you, right? Just join us and we will teach you from scratch. But if you want to orient yourself well, then do some reading, hard reading. Pick up a book, doesn't have to be technical. It could really be a classic in literature, but you will orient your mind towards university studies. Yeah, that would be my advice.
Okay, thank you so much.
Okay, we have two very interesting questions in the Q&A section. So one of it is, what could chemical engineers do to contribute or solve environmental issues that the world is currently facing? And would it be a highly relevant industry considering how sustainability is not a major consideration for some businesses?
That's such a great question, right? And it's a complex question. But let's first start off with the fact that you've heard from two alumni, right? Who have actually done such a diverse range of things, including big capital projects, right? Now, uh, given the energy crisis around the world in general, right? Energy is a big thing, and the crude oil is used not just for energy, but also for actually making molecules and materials that sustain our daily lives, right? So as you heard from the alumni, the industry is vital to the functioning of the world. So that's one, right? Now let's specifically talk about environmental issues. Chemical engineers are at the absolute forefront in really thinking about, let's say, energy transition, right? So energy transition would be moving away from more fossil-based sources of fuel towards more bio-based sources. You could think about biomass for fuels, but also for valuable materials like pharmaceuticals, right? So chemical engineers are at the forefront of that. Chemical engineers are at the forefront of, for example, electrifying chemical manufacturing. So instead of going from fossil-based energy to run manufacturing, to really think about, in principle, whether we could use renewables to be able to run a chemical industry, right? We are at the forefront of sustainability in the context of healthcare. And you will actually see professors in NUS chemical engineering work on all these topics. You'll be exposed to the professors in your courses, but you could also do research or projects with the professors in this context. Decarbonization is a huge driving theme for our entire department. We are one of the leading departments in the world for decarbonization, right? So I think there's a lot of opportunities, Calista, to contribute and to solve environmental issues. So yeah, I hope that addresses.
Okay, on the topic of decarbonization, the next question is also something about low carbon. So, could I ask more about
Yeah.
what you learned in the minor of hydrogen and low carbon technology and how it compares to the specialization of safety and sustainability? Because I am interested in the sustainability aspect of being a chemical engineer.
Suraj, you want to start? Or I can go, but maybe you want to start and then I can add.
Yeah, sure. Maybe I can start first. So for the minor in hydrogen and low carbon technology, so it's mainly to prepare you for to work in the industry or do R&D. But the focus will be more on hydrogen production and how to store it and how to utilize it. So because these are some of the things which Singapore is planning for in the future. So that will be for the minor. As for the one which is on safety and sustainability, that is going to be more on giving you a very broad overview of what are the different aspects or related to safety and sustainability that you need to take care of when you want to design, maintain, and operate chemical processes. So what will happen is for the safety and sustainability, you will actually have a wide range of technical electives to choose from. So that includes two of the courses which Rudolph just mentioned, pinch analysis and control of industrial processes. Plus, you will have a whole list of courses, circular economy, green chemistry, and so on. So that will be a huge basket to choose from. Whereas for the hydrogen one, because the focus is mainly on hydrogen energy, so most of the electives will be tuned towards that. So I think we have an elective hydrogen energy and technology. So that will be one, and there will be some electives that you can take from. If I'm not wrong, I think it's from MSE, Materials Science and Engineering, the department. And of course, you also need to fulfill, you also have chemical process safety as one of the electives that you can choose from. So that is my input on this two. One is more focused on hydrogen, the other is more broad. Yeah.
Yeah, absolutely. Right. So firstly, right, there is always overlap It is one discipline.
Yeah.
There is always. So it's about what is the focus, right? So as the name suggests, one is more on alternative sources, alternative fuels, right? So hydrogen is an alternative fuel. You could think about ammonia as an alternative, right? So that's one. And then what would it take for an entire supply chain to run on that, right? And low carbon technology is allied to that, right? Low carbon technology could be uh, at the start using a non-fossil fuel, but also how could you have technology that have very much more mitigated carbon emissions? So both sides, right? So that's there. And safety and sustainability is, as Surat said, broader in its scope, right? And always as a student, right, don't compare the minors. Like it's not this versus this. Take a look at the classes and ask yourself, right, what do I think I want to do? And do it. And or you could be like Rudolph. You can say, look, man, I like both these. I'm going to do both of these. And there are opportunities to do that as well.
Where can we have another question. Where can we search for research projects in the department? Is there a website or do we just ask the professors? And what procedures will we need to fulfill to apply to participate?
Okay, so two ways. Firstly, let's just say this. Our administrative staff in NUS Chemical Engineering is amazing. You're looking at one on the screen right now, right? And they're going to help you a lot in sort of navigating this once you join us. But to answer this question, there are two ways. One way is you could do something called a Europe, okay? And for that, there is a portal within the NUS once you join us where you can look at posted projects. But that's not the only way. I have routinely students approach me and say they're interested in doing a project. And then if the professor is interested, they could, on the initiation of the student, propose a Europe project, an undergraduate research opportunities project, right? So there are many ways, and we guide you through these in making these choices.
And just to add on, you also have the final year research project that you
Yes.
can consider taking on top of the design project.
Yes.
Because design project will be compulsory, and on top of that, if you want to take a dissertation in your final year, you could
Yeah.
use two of your unrestricted electives to do that. Yeah.
Yeah.
Very sorry to bother again.
Yeah.
You mentioned like the introductory books for like chemical engineering, right? Is there like any particular ones
Oh.
that you recommend?
So Alicia, honestly, I don't follow. So I teach introductory chemical engineering. We don't follow a textbook.
Yeah.
Yeah.
Oh, okay.
So I think it's fine. If you revise your math and just generally spend your time sort of orienting yourself, it's fine. There are many intro to chem-eng books, but these come with different titles. Yeah, these could be unit operations in chemical engineering or chemical processes, and those can get very technical very quick, right? So they get beyond the introduction very quick. So we have a whole year to introduce you to the topic in 2 semesters. We call that chemical engineering principles and practice. So I'll be the lecturer for the first semester course. So I think it's fine. Yeah, technically, perhaps just your math and your basic sciences, right? You can brush up on your physics if you've taken physics, chemistry if you've taken chemistry. That should suffice. Come in with that.
Okay, that's very reassuring. Thank you so much. Another thing I wanted to ask was like considering like the internships in like year 3, because um I remember like hearing about like Talent Connect and like self-sourced internships and like what are like the differences between both of them.
Coco, you want to
Yeah,
take a
maybe
stab
I
at
can
that?
take this question. So, for the year 3 compulsory internship for the A-level cohort, most of the students will go through Talent Connect. So, the companies available on Talent Connect are companies who have already been posting listings, internship listings regularly. But if you have other interests, students are also free to go source their own self-source internship. Of course, this is with the approval of the internship committee. It has to meet certain requirements related to the technical side of things.
Oh, okay, Ken. Thank you so much.
We have an interesting question.
Yeah.
What is the
It's the best hits, right? The top hits.
Yeah.
This is one of the very common questions. What's the difference between a major in chemical engineering and the major in chemistry? So let's first say the word engineering matters. Okay, so the word chemical engineering matters. So look, the simplest way to think about this is you've done up to now up to high school, right, or junior college. You've done chemistry experiments in your lab. A chemist is really focused on the actual on the chemistry and making perhaps new bonds form, making new molecules, right? And perhaps in the discovery side of things, right? A chemical engineer definitely can be interested in that, but for us as engineers, what's the big difference? Chemical engineers take a discovery, or maybe when they make a discovery, the next question we ask is, how are we going to make this impact as large a cross section of the population as possible? So instead of making a chemical or a new medicine on a lab bench, we ask, what does it take to take that discovery and make enough dosage for the whole world, right? And for that, you need to know a whole lot more than just chemistry. So that's really the basic difference. The word engineering matters. And you again, I refer you back to our wonderful alums who've done these large-scale projects, right? It's everything from technology to techno-economic analysis to regulations to legal. Yeah, that's the word engineering matters.
Yeah, so just to add on, it is things like, okay, you want to make something, right? A plus B equals to C. That's chemistry. A plus B equals to C. But in the course of getting A to your plant, what do you need? The ship to
Yeah.
come in. How big the ship? The every cargo say is X tons. How do you transfer X tons and where you gonna store it, right? After you store it, how are you gonna get A and B together in the same place? Can they mix together without exploding? Can they just mix together safely? What temperature do you need them to become C? Why don't they just after it becomes C, how do you transport it? Where do you go? Do you need to store it straight away? How does it go to the customer? Things like that. Yeah. Does it float? Does it sink? Is it solid, liquid? Things. How do you transport all these things? How do you transport solid? How do you transport liquid? How do you transport gas? Things like that. That's chemical engineering.
Amen. Thank you, Dick Young. You speak from so much experience. So I hope that addresses the question there. It is a big difference. Other questions for our alumni, I think, because our alumni have gone on to have so many diverse experiences. You guys get asked about life. Look, we profs can answer some things, but there's a lot of things we can't answer. Or questions about student life to Abby and Rudolph.
Maybe like what's like one like difficulty you faced? Like maybe like I did this like just in general, like maybe in like the workforce or like in the university course in general, and like how did you overcome it? Did you like learn anything significant? Like you had to like pick one like really major one that like resonated with you a lot.
Thanks, Alicia. They're great. I think we can ask our alumni because in their professional lives, they would have faced so many challenges, right? So Taekyong, Ingjun.
Challenges. I think every day is a challenge. Um, Yeah, especially these days, everyone is trying to increase price because of shortage of supply. So that's where you apply your whatever you learn from engineering, all the numbers. You look at the numbers, you ask for a breakdown. What is it that increased? Or diesel's increased, but why are you charging me? Diesel has only increased 100%. Why are you charging me 200%? Why? Things like that. You apply some sort of analytical thinking in your thing, in your daily work. And then the other challenge is, of course, keeping yourself relevant because the world has, I mean, from when I graduated from until now, the world has changed a lot, right? I mean, me, Prof Sai, we used to calculate by hand, one calculator calculate everything. These days, you plug everything into some AI and then they do for you all the formulas and stuff like that. We- So still, I mean, we have to learn, right? I mean, we have to keep up with the times. So we have to learn how to use AI to, you know, work for us so that, we don't get mastered by AI, but we master it ourselves. And then, yeah, I mean, of course, communication with people is important as well, besides academics, right? You have to learn how to interact with people, you know, um, how to get things done even with difficult people, because there will be difficult people. And then how do you let people know what you want and then voice out to other people, things like that. So yeah, it's not just academics, but communications as well, and how to manage many different things. Yeah.
All right. um, well, I started off, well, projects was not my first job. It was my second job. Um, but as a very young project engineer, and project people are supposed to know a lot. They're supposed to, everything is done to them. And somehow they are supposed to just think they know everything. So it was a challenge for me as a young project engineer. Um, and I find that what really helped me then was the fact that I could take up a PFD, a PNID, and from there extrapolate the understanding of what I'm looking at as a project. That helped me understand the scope of a project much faster. And that was because of my chemical engineering background, which helps me to interact with my engineers. Because lucky or not, maybe nowadays engineers are a bit different, but in the workforce, engineers are a bit more, they have a particular characteristic. If you are not too grounded in your knowledge or what you know, and you talk to them, they can be a bit not too polite sometimes. So I had to deal with a lot of such engineers in my career, senior, young, um, and what really helped me then was the fact that I was taking those drawings, understanding those drawings, and talking to them. If I don't understand, I ask. Because I know this pipeline is supposed to do this for this process. You're supposed to have this process control for all this. What I didn't understand was the electrical component. What I didn't understand was the civil component, the structural component, and I went to ask them. And because I was talking to them as an engineer, as a chemical engineer background, and asking them on an engineer to engineer basis, that helped me close the gap a lot. And it helps me in my job as well, because if I cannot gain the trust of my engineers, sometimes it can be hard to push them to deliver the things I need. And if I can't deliver things I need to, if I can't deliver drawings, I get scolded by my PM. And then my client will call me as well. Why are the drawings not on my desk yet? Why are my workers, not on the site building whatever that I need to see built? And why is my money not coming in? So it helps. So I'm always very grateful for my background, although I don't think I was a very good student back then, but I'm always very grateful for the overview, the structure, the framework that was given to me at that point in time. And this is not only about technical, right? Projects is about technical, it's about legal, it's about contracts, it's about commercial, it's about money as well. There's an important part of my job that has to do with, back then, has to do with money, contracts. Are we on budget? How much are we spending? Is there any change order? Is there any scope change? And when I need to go to my client to talk about scope change, I need to be able to explain to them why is there such a scope change. If I change a valve, what does it imply? Why am I looking at cost in civil cost? Why am I looking at cost change in engineering? Why am I looking at price change in electrical? How does it all come in? And it all go back to your understanding of why I need to change this process system. And those are the implications that comes in. And chemical engineering gives you that leverage to tee off and to understand, as a spider web, to understand how everything else is being affected because of this one decision you make on the process control system, on a process pipeline, on a valve. So because of that, I was able to explain a bit more to my client and get scolded a bit lesser. Or rather, they become my friends later. I mean, we still argue, we still fight, but at least you're not talking to them only from a contract or commercial basis and say, now this is my scope change, I need to charge you this and this and this. But you're able to explain to them on a technical basis, you're able to talk to them on a commercial basis as well. And at the same time, you're able to talk back to your engineers. Look, if you do this, this is my cost. You can go to a process person and say, if you want to change this valve, you want to change this process control system, this is the cost. And very early in my career, because you don't have all this knowledge, you can't leverage off. I guess it's very hard for me to communicate with the first engineer. Why? Maybe they shouldn't do this decision because the implication. But later on, with all this knowledge, it takes a while, but it does help to have all this chemical engineering idea and the concept and the spider web that you can develop from there. To talk there and say, look, if you do this, these are the implications downstream, and these are the implications on site. Is that what we want? So that is how chemical engineering has advantage to give you a very broad perspective of things. Not saying that other engineers can't, they can't, but I have to be a bit upfront and say that chemical engineers have advantage in that because it's easy for us to take up PFD, a PNID, and see how the system works across the plant. There are my peers who, even now in my current role, I do benchmarking. I look at capital projects against industry standards, against industry average, and I tell clients to whether their projects are doing well, doing bad, no good, or whether how are they bringing in technology. Even my peers now tell me that it's hard for them sometimes to understand in terms of technicality what is going on, and they envy actually people with chemical engineering background because they find that or rather they feel that we understand things a bit faster because of our knowledge, right? So back to you guys, Prof.
Thank you, Injun. And there is a question in the chat for our current students as well, because our alumni have spoken about the challenges, right, in professional life. There's a question about current students. Like, may I ask what was the hardest thing you had to adapt to, coming from a PCME student who's finished A levels, but poly works too? And are there unique practices you apply now on how to balance all your commitments? That's a great question. And Abhi and Rudolph have shared how many commitments they do, and yet they've done very well in their coursework. So Abhi, Rudolph, you have some words to say for that?
Okay, so I was from A-level PCME also. And I think like how you perform in uni really depends on your learning style. Because coming from JC, I feel like it was very structured and like everything is planned out for you. But uni, it's more flexible. So if you are a more flexible kind of learner, then I think you are gonna thrive in uni. But if you need the structure, then I think you should like schedule your time well. A lot of my friends, they have like these insane Google calendars where they block out time for every single thing they do every day. So yeah, that's like my main advice. Just be consistent with everything you do. Yeah.
I think for me, maybe I could share a bit more about like how I adapted a bit towards like the more heavily technical modules. So like I shared earlier, because I was doing like the specialization modules, right? So sometimes they tend to go like into pretty in-depth into like newer technologies or things that may not be covered very deeply in the foundational courses. So for me, I think what I usually like to do is if I find a lecture like very abstract and a bit hard to understand, I'll actually, so first avenue is always the textbook. So you want to reach the textbook and then skim through and see whether you can understand from the textbook. But if you find that difficult, for me, I'll actually go onto YouTube to actually watch like a 20-minute summary to get like a first idea of like how a rough gauge of like how it works. Maybe it could be a learning style thing as well, because like maybe I prefer that kind of format as well. Then after watching that summary, then I head on towards watching the entire lecture as well as making my notes. So that is actually one way. As for unique practices to apply and balance all the commitments, I think rather than unique practices, I think it's something that everyone will know lah. So it's like your scheduling. Make sure that you plan out your timetable. Yeah, because usually I think in uni, at least for me, how it works that usually up to recess week, usually everything feels very smooth sailing, but suddenly like everything starts to snowball after recess week. So yeah, so plan early and make sure that you know everything is within time. Uh, Personally I plan and then it's not within time, so also try to remember to give yourself buffer time to adapt as well. Yeah.
Okay. Avi and Rudolph, there's another question for both of you. Do you have any advice in terms of choosing what modules or UEs to study? I've heard advice to choose modules that you're truly interested in, or others say to take easy modules to score easily for higher GPA, which brings the question, does GPA matter more or internship experience?
I would say you should choose modules that you're actually interested in. Because as for me, I feel like I tend to do better in modules that I actually like compared to modules that I have to force myself to learn and like. So definitely choose something that you're interested in. And I think there's also like this safety net of SU options. So even if you like something and you didn't do as well as you thought you would, there's always your SUs where you can um overcome your little setback. Yeah. Rudolph, do you have anything?
In terms of choosing modules, right? I think rather than giving specific modules, because I think different people have like different interests. But I think what you could do is perhaps speak to your seniors, uh, or even the professors. You can probably maybe you can choose to maybe drop them an email or something if you would like to find out about a certain course. I think I did that before with like process control before. Yeah. So get a feel of like so firstly understand what the course is about. And next thing is find out what the industry needs in terms of like what you're interested in. So this will include like going for industrial talks, maybe going to career fairs, speaking to like professionals. Then you find out, then you think about whether like or whether this skill is like very relevant in the career that you want. Then you take that course and then adjust accordingly. And yeah, and honestly, internship is a very big opportunity for you to learn. But I think by then usually you will have already like have a idea of like how you want to structure a year 3 and year 4. So best is if you can try to secure maybe summer internships as well in the industries that you're interested in. Um, no Talent Connect usually the companies do not post there for summer internships. So from my understanding, most of my friends actually self-source their summer intern. So yeah, if you're interested in that, you probably need to actually go and do the legwork to get and uh, get that kind of opportunities by like contacting the HRs and emailing them to say that you're interested.
Yeah, if I can add as a professor, right? Because there is that little question, right? And you would be tempted to take modules that are perceived as easy or whatever, right? With the driving force that look, man, I mean, a higher GPA. The world has changed a lot, actually. I've been at NUS 2 decades, and even in those 2 decades, right, the world has changed a lot. You can ask yourself this, right? We have two very distinguished alumni with us today, right? What would so would they be more interested in just a number describing you, right? As whatever, 5 out of 5 GPA. Would that be more important? Or would they be more impressed by you just sitting down with them for 15 minutes, talking about your interests, and also talking about your experiences, making connections with lots of things between your discipline and the outside world. You can ask yourself, right? And it's a simple question to answer. What would be more valuable for the workplace, right? So communication skills, you've heard this again and again. A lot of this now comes together. So a student, you are not just your GPA. You are actually way more than just your GPA. And the more you go into professional life, the less that matters. So I'll also let our alumni maybe chime in a little bit about this.
Okay, maybe just a quick one. GPA is for HR, right? So it gets you through the window. Okay, when you have a decent GPA, HR filters you, okay, and then sets you up an interview. Now, interview with the hiring department. That's where you can share about your internship experience, and then we look at how you adapt to different circumstances and things like that. So both are important. One gets the window open. The other one gets you the letter. Yeah.
Well, GPA is definitely important, and there's no two ways about it. But okay, let me put it this way. Um, I'm a chemical engineer graduate. My GPA that then was 3.3, but I also have an MBA, and I also have a Master of Law. I got Dean list for MBA. I got a valedictorian for my Master of Law. What does it mean? It really doesn't really mean everything. But when people look at me, they look at me as a person who has knowledge of technical, of commercial, of legal. And this intersection of knowledge interests them. So GPA will be important for your first job. It's more get through it. It's important to set yourself base right. But as you go on, and what NUS cultivate as well, and what most of you are being told as well, is you need to continue to upgrade, you need to continue to learn. And that's much more important. So your time in NUS, spend it on learning how to learn, how to unlearn, how to learn. That I think that will make the professors much more happy than you presenting them from there by 1 point every other day. Right.
Oh, actually, maybe I can add on a bit also regarding just the earlier pointer. So maybe if you are interested in a very high technical module, but you are maybe worried in terms of like workload or like GPA side of things, right? You can also choose to audit the module as well. So you can actually take on attend the
Yeah.
modules as like a non-graded option. Then you just attend and then you won't be graded, but you get access to all the study materials. I think the profs probably have like more information on that. Yeah, but that was something I really wish I did. I found out quite late lah. I found out in year 4 lah. So yeah.
Yeah, indeed. All you can do is just talk to the prof and say, I just want to sit in the class and have access to the class materials. None of us are going to say no.
Okay,
Coco,
we
how
have
are we on time?
yes, we have one. We'll take one last question for Taek Yong and Ingjin before we do our feedback session. Yes. How should I practice soft skills and people skills, non-technical side of things in view of preparing for a chemical engineering career, especially since chemical engineers tend to focus on project side of things?
So, you're still explaining technical things to people, but you need to explain things. You need to explain what's in your head to the person listening to you. So that's the one of the hardest thing because if you've done the calculations and all, it's all very clear to you, right? But when you are explaining to somebody why you arrive at this conclusion, the fella didn't do the calculation, he doesn't know. So you need to simplify in a way that the person who is listening or the stakeholder knows what you're talking about, right? So how should you practice soft skills? Well, talk to your professors. You have a question, talk to them. Look at them how they break up the problem into different small little parts that is digestible. And then you have a chance to interact with industry people. Talk to them. What are they? What are latest things that the company is interested about? What is the company worried about? What is the industry focusing on? Things like that. So you get to see perspectives from other people's viewpoint, and then you understand what is their interest, and then that's how you practice. So the most important thing about soft skill about people skills is you know you're engaging people. You want to engage in a way that's useful to the person that you're talking to, right? If you're just like downloading stuff to them, right, they're not listening because it's of no interest to them. You need to know what is. So you need to listen to them first, and then you answer in a way that that is helpful to them. Yeah.
I think that's a question that every one of us is still struggling with at every stage of a career. But I find that to me, the more important thing is to learn to listen. Start by listening to what your prof is saying, and not only about what the exam is testing for. But I think that one of the more important things I find is to learn how to listen to others when they talk. And I think that will help you a lot in your soft skill. And it varies, right? Sometimes you just talk about commercial stuff to some people. They are very keen. You talk about what the company is interested in. They're very keen, but some people are not so keen on it. Some people are more keen on what's affecting their day-to-day job. So being able to understand that and what drives them is something that we all need to learn along the way. And I think that starts from learning how to listen to what they're saying.